We are starting off this module with what is energy and then how does chemistry play into energy? What's the energy associated with chemical reactions and processes of heat transfer and things like that. So we are going to be focusing more on the chemical reaction side of that, of course, because this is chemistry. There's a lot of energy that you study in physics or physical science as well. But again, we're going to stick kind of on the chemistry side of things. So I'm going to give you kind of an overview, and then we're going to get more into the specifics of energy related to chemical reactions. So what is thermochemistry? This whole unit is called thermochemistry. It is the study of the heat transfer with reactions, of course. So some reactions give off heat, some reactions require heat or energy in order to happen. So they might get colder, they might get hotter. It really just depends on what's going on with that chemical reaction specifically. There is always some type of energy change between reactants and products if you have a chemical reaction. So a couple of vocabulary terms that are going to be very important include energy, of course. And in any physical science class, you would have defined this as the capacity to do work or produce heat. Again, we're going to focus on this side, the producing heat, but energy can, of course, do work as well, right? If you have energy, you can do work. That's more the physics side of things, okay? So law of conservation of energy then is, of course, going to govern what we can measure and the heat transfer we can measure. And the law of conservation of energy, just like law of conservation of mass, cannot be created or destroyed. And I'm going to add a little caveat onto there, only transferred. So you can always transfer energy. That's what heat is, the energy being transferred from the hotter thing to a colder thing. And that is possible, but it cannot just disappear. It has to go somewhere. So however much energy is lost from one thing has to be gained by the other because it doesn't just disappear. So the two types of energy are kinetic energy and potential energy. We will be focusing on the kinetic energy of molecules, so like how fast they're moving, or the energy of motion. Of course, there's also potential energy. That's the energy of position, like how high you are. You have a higher potential energy. Again, that is more of a physics thing. Calculating potential energy would be the gravitational constant times the height times your mass. Again, not something we're going to be focusing on. We'll be focusing on energy of motion and mostly particles moving. And to calculate the kinetic energy of anything, the calculation is 1/2 mv squared, mass times velocity squared. This is, again, when we're referencing like me moving, like physics, okay? I didn't box this in because you will not be using this equation to calculate the energy associated with molecules because they have such a small mass, and actually determining the molecule velocity is very difficult. So this does tell you the kinetic energy of things like molecules. It's just difficult to do this way. So I will be giving you some different equations. But again, we're focusing on kinetic energy, not the potential energy. All right. So energy in general, the units we will be using are joules. Joule is the SI unit for energy. A joule is actually a very small amount of energy. And so a lot of the times we use kilojoules instead. So joules, kilojoules, there's of course 1,000 joules in a kilojoule because it is on the metric system. The non-SI unit, or one that we also use a lot in this class, is the calorie, which is something you're probably more familiar with. A calorie, by definition, is the amount of heat or energy used to raise 1 gram of water, so like 1 milliliter of water, by 1 degree Celsius. As you can imagine, that is a very small amount of energy. So 1 calorie is a very, very small amount of energy, as is 1 joule. So I've got you some of the conversions over here. All of these are on your equation sheet. 1 kilojoule is 1,000 joules. How joules and calories are related. 1 joule is 4.184 calories. Notice this is a lowercase c. Okay, I did that for a reason. It's a lowercase c calories because there's actually also an uppercase c calories, which is the same thing as a kilocalorie. So there are 1,000 calories in a kilocalorie. A kilocalorie is also a capital C calorie. Now, why do I tell you this? Because this is actually the calories used in food. If we go by this definition of calorie over here, the amount of heat used to raise 1 gram of water by 1 degree Celsius, I get very, very small amount of energy. So if you look at a granola bar and it's 190 calories, it's not 190 of these calories. It's actually 190,000 of these calories. So they've just converted it into, on the wrapper, what you're seeing, that number, that 190 is actually kilocalories, or we call it capital C calories. So if you look on packages like in the UK, it says kilocalories. On ours, it is a capital C calorie. So these are not the same thing. There are 1,000 calories in a kilocalorie, or the calorie on your labels. I think the reason we do that is because putting 190,000 calories on something is just a little unnecessary. So we divide it by 1,000, it's 190 calories is what we would say. Okay, so that's what you're going to see for all of our units. Not too many units, nothing going too crazy. So what is the kinetic energy with regard to molecules? I kind of already talked about this, but it's those molecules moving, right? We know they're bouncing all over the place, moving constantly. That is based on their kinetic energy. That's their kinetic energy. It has to do with how fast they're moving. Now, molecules also vibrate and have molecular motion, and so they don't just move in a straight line. That's part of their kinetic energy. They also bend and stretch. These are things that you would get more into if you take physical chemistry in the future, the energy associated with the bending and the stretching of the molecules, or their movement. They can be rotating, or their translational motion. There's a whole bunch of different ways that molecules move, and those all play into the kinetic energy of a system or of molecules. The potential energy regarding molecules is found in the bonds. Okay, so the energy associated with a bond is the energy associated with an attraction between like an oxygen and a hydrogen in that bond. There's also energy associated with the attraction between one molecule and another molecule. So that's where the potential energy of molecules is found. Okay. Now, a lot of the times, potential energy with bonds is kind of difficult to kind of wrap your head around, because it's not like the energy in the bond, because it actually requires energy to break a bond, and it gives off energy when bonds are formed. And we're going to get more into that when we talk about bonds in, I think, the next module. So don't get too caught up on that right now, but we'll go more in depth with those in the future.